in the structure of the cell wall. That'll become more clear to you later. For right now, I'll kind of take my word for it, but that'll become more clear later on. But what we did talk about right at the end on Tuesday was this. If he knows a difference in treatment, so keep in mind that the gram-positive cells can be treated with antibiotics, and the gram-negatives pretty much not. I mean, you can do it, it's just not very effective. And the idea is that antibiotics inhibit protein synthesis. But the key there is they inhibit protein synthesis of new cells. For already existing cells, the proteins are already made. I mean, everything's already in place. So antibiotics do not affect already existing cells. They only affect new cells that are trying to form everything. So the implication there then is, since the antibiotics affect gram-positive cells, the gram-positive cells must have lots of protein. Otherwise, they wouldn't be affected. And the gram-negative cells must have very little. So again, it's new cells being affected, not the existing cells. But what the deal is with the antibiotics is that the antibiotics prevent new cells from forming, so your immune system can work on the already existing cells. It's not falling behind. And by the way, this is why when you're taking antibiotics, it usually takes a couple days before they take effect, because the existing cells are still there. And it takes that long for the immune system to start working away at getting rid of those cells. So you don't get better right away when you take antibiotics. But after a couple of days you do. That's because you're not making new ones, and the immune system is getting rid of the old ones. And I can't remember if I actually commented on this or not. We did, okay. So just as a reminder, it's good only on cells 24 hours of age or less, because that is now an old cell. The cell wall breaks down. And once it starts breaking down, you can no longer get a difference between gram-positive and gram-negative, because then they all kind of become the same. So that's a repeat right at the end of Tuesday. But any questions on any of that? Because we're going to come back to that over and over again all quarter. Okay, again, we'll be doing it next week, so you'll get some more of it next week. Okay, the next of these stains is the acid-fast stain. It's a nice procedure, and we used to do it in class, but we no longer can do it because of last year, I believe, it turned out a couple of students were allergic to a couple of the ingredients. You know, I've done this for 10 years. The first time we've ever had an issue, and because of it, we had to stop. But I kind of think it wasn't the right answer. But at any rate, because of the allergy, so nothing happened. It's just these two students were allergic. At any rate, the acid-fast stain is still worth knowing about. It detects a bacteria called mycobacteria. Mycobacteria. Notice causes tuberculosis and leprosy. TB and leprosy. Most of you have heard of leprosy, but I've discovered most people don't really exactly know what it is. I spent 2 years in Ghana, in West Africa, and we had leprosy all over the place. So I know exactly what it is. Basically, it's a disease that attacks the soft tissues of your body, particularly in the face. So these guys that I used to see, their lips were gone, you know, soft tissue. They were eaten away. The front part of the nose was gone. The ears are gone. And so frankly, not pretty. There's no way of disguising it. It wasn't pretty. But also a little bit, well, a lot, to my surprise, because I knew what leprosy was. In many cases, the fingers were gone. Now, the fingers are not exactly soft tissue. There's a few bones in there. So I actually never really understood why were the fingers gone. I only learned a couple years ago what the deal was. And I don't exactly know if it's true, but the best thing I've come up with so far. And that is that the leprosy would also attack the ligaments that were connecting the bones in the fingers. So the ligaments would be eaten away, and then the bones were actually no longer connected. And then when the leprosy would attack the soft tissue of the fingers, the bones would just kind of fall off.
So where would they go? You just
Probably just decompose. Thank you for asking. So just decompose. At any rate,
put them in there.
so that's leprosy. Now you know. But mostly it attacks soft tissues. The mycobacteria. So once again, you do your heat fixing, you do your smearing and all that kind of stuff. And then, step one, you add carbofucin. Carbofucin is mostly a pinkish stain, but we'll just say that the cell turned red. It's more of a light red, but turn red. Heat the cell. By heating the cell, it makes it easier to add the stain. Again, well, we won't be doing it next week. So the heating is to soften the cell, make it easier to stain. Rinse off the excess. We'll be doing that a bunch. And then again, the decolorizing step. So decolorizing this time with acid and alcohol, and thus acid-fast stain. 3% alcohol, 95% alcohol, I'm sorry, 3% acid, 95% alcohol. So what that means, of course, is 2% water. So after the decolorizing step, you will have either red cells or clear cells. After the decolorizing, yeah. Step 2.
You
Then
said
after
red or
you,
clear?
I'm sorry, what?
Red or clear cell?
Red or clear. And then, step 3 is, again now, the counter stain. Counter stain means you're adding a second stain. In this case, methylene blue. Now remember, counter stains do not stain cells that are already stained. They only stain clear cells. So, after the counter stain, you will have either red cells or blue cells. And the red cells, well, the red cells are your positive result. That is acid-fast. That means mycobacteria. So the red cells are your positive result. It means you've got mycobacteria. Most bacteria are not mycobacteria. So therefore, usually you're going to get blue. Blue would be your negative result. And you don't know what the bacteria is, you just know that it isn't mycobacteria.
I had a tuberculosis test done and my skin showed reactions and I had a whole now.
Okay, so that's the procedure, but how does it work? Not that anybody cares, but we'll do it anyhow. It works because mycobacteria contain an extra lipid called mycolic acid. Now, this is in the cell wall. Mycobacteria contain mycolic acid. It's an extra lipid.
You said it's an extra lipid?
It's an extra lipid in the cell wall. And because of that extra lipid, it makes it difficult to stain the cell. The various stains cannot get through the cell wall. So, carbofucin has a high affinity, a high attraction for cellular wax, like mycolic acid. To rephrase that into something that might actually be understandable, carbofucin prefers to bind to lipid than to bind to acid alcohol. Acid alcohol is your decolorizer. So you've got your cell stained red with carbofuchsin, then you add the decolorizer. With most cells with no mycolic acid, well, there's no choice. You got the acid alcohol, the carbofuchsin dissolves, goes off in the acid alcohol. But with mycobacteria, you've got that extra lipid. So the carbofuchsin prefers the extra lipid. So it stays bound to the cell wall. It does not dissolve into the acid alcohol. That's why with mycobacteria, it stays red. But with everything else, without the mycolic acid, it loses the color. So carbofuchsin only stays in the presence of decolorizer if you've got the mycolic acid. If it's not there, then it decolorizes. Another stain that we no longer do, but this one, we don't do it because it didn't work, is negative staining. Negative staining. Every so often, it's really hard to stain a bacteria. And sometimes just because it's hard, like with the mycobacteria, the mycolic acid. But sometimes it's because there's an extra structure called a capsule. You already know cells have, all cells, have a cell membrane. Bacteria have a cell wall. And now sometimes, so this is a maybe, there's an extra structure called a capsule, made out of carbohydrate. That's a maybe, but sometimes that capsule is there and it prevents the stain from getting to the cell. It's a barrier. There could be other reasons too why it doesn't stain, but that's one reason. So basically, sometimes you cannot stain the cell. So instead, you do this negative stain, which stains everything else except the cell. So you end up with a dark background and a clear cell. So with this, you're seeing kind of everything dark except for the cell. So you see the shape of it, the structure of it, but that's about it. The reason it didn't work for us, the reason I kind of quit doing it, is because usually people have too much of the stain. The stain would be either into ink or nigrosin, which is actually the same thing. But they have too much of it. So even if the cells were clear, but there'd be so much of the stain would actually be on top of the cells. So you can see it. Anyhow, it really didn't work. It was frustrating, and I just quit doing it. Still at least know what it is. Now finally, the endospore stain. Endospore, oh yeah.
So the point of that test is just to see if it has a capsule?
I'm sorry.
The point of that test is just to see if it has a capsule?
No,
What's
the
main-
capsule is just one reason why you might not be able to stain the cell. The question is the point of the negative stain to see the capsule? Not necessarily, because you don't necessarily know there is a capsule. But you're just trying to, presumably you're trying to stain the cell by other means, and then you're failing. So if you can't stain it by other means, you do the negative stain.
Okay.
And like I say, there might be a capsule, there might not. You don't actually know. But you might not be able to stain for other reasons. The final thing is the endospore stain. The endospores themselves are not quite like seeds, but they help the bacteria survive severe environmental stress. So for example, severe drought, severe heat, severe cold, vacuum, outer space, that kind of thing. There have been endospores found in the tombs of the pharaohs, and the ones that weren't robbed, like grave robbers. So some of these tombs, these pyramids were opened up 5,000 years old. Endospores were found, and once they were kind of exposed to the normal outside environment, they germinated. They came to life after 5,000 years. When the space program here was first getting started, people were really kind of worried, well, geez, maybe we'll go into outer space and find extra